Assalamualaikum warahmatullahi wabarakatuh. Welcome to subtopic 6.5, which is about problems related to having single line, parallel lines, and perpendicular lines on the graph. So basically, when you have a single line on a graph, some of the problems that you will be seeing related to single line will be finding the slope, finding the distance between 2 points on a line, finding the midpoint of a line, and maybe finding a point where that particular point divides a line in a specific ratio. And when you have two lines on a graph, the interesting problems that you might be asked would be related to the lines being perpendicular or parallel. And for example, you may be asked to find the distance between two lines or finding the point where the intersection occurs between two lines. So in this video, we will just be looking at these two subtopics here, and the rest of them will be covered in the next videos. So if you have a single line on a graph, one of the problem that is often asked is to find the slope of that particular line. And this actually, you have already seen this in the previous chapter, but let's just reiterate this again. Let's say you have point P at x1 and y1, and you have another point which is Q, x2, y2. So notice that x1 is not equal to x2, so there are really two distinct points on a line. And then if you want to find the slope of the line, the formula is given as such. So this is something familiar which you have already seen previously. So that is a formula to find the slope of a single line. So next, when you have a single line on a graph, you might be interested to find the distance between 2 points on a line, and the formula to find the distance is given by this one. Okay, so here again we have point P at x1, y1 and point Q at x2, y2. So those two are two distinctive points on a line, and therefore the distance between these points P and Q is given by this formula. So in the next slide, I will be talking about how can this formula is explained using a simple diagram. Okay, so we are going to look at how this formula is constructed using a simple diagram. And this is not something too complicated, because it is actually based on a very basic idea of Pythagoras Theorem. So recall the Pythagoras Theorem, which you have seen many years back when you were in schools. So if you have a right angle triangle, okay, so this is a right angle triangle where the degrees is so this is 90 degrees. So Pythagoras Theorem basically talks about the relationship between the sides, okay, so between the sides of the right angle triangle. So what's the relationship between these three sides? Now, if the length of this one is given by A and this one is B, so this is the length, okay, so A is the length, so B is also the length. Therefore, you can find the length of this one. So this is the hypotenuse. So you can find the length of it using this formula. Okay, you take A square, you add up with B square, and then you find its square root. So if you compare this with the problem of finding the distance between 2 points on a line, so let's say that you have point over here, you have point P. So P is x1, y1, and here you have point Q. So these are two distinct points on a line. So this is Q, x2, y2. So basically this is point x1 on the graph, and this is point y1. Okay, and over here this is point y2, and this is point refers to point x2. So based on this line, I'm sure you can see that it is possible to construct a right angle triangle. So this is the right angle triangle. I'm constructing a right angle triangle where the degrees here is 90 degrees. Okay, so now based on this simple diagram, I'm sure that I can find the length of this side here. So the length or the distance between this point and this point. So this length is what we can call as A, and this is B. And so if you look at this graph, you can see that in order to find A must be equals to this is point x2, so you can have x2 minus x1 and you will get the length of A. So here A is actually can be obtained by finding A is x2 minus x1. Okay, similar thing with finding the length of B. So this can be obtained by having y2. Okay, so y2, this is point y2 minus at this point is y1. So here will be B is equal to y2 minus y1. Now our interest is to find the distance of this line. So this is actually hypotenuse, and according to the Pythagoras theorem, the distance here, so this is the distance that you are interested to find. What is the distance? So according to the formula, it will be the square root of a square plus b square. So in this case, the distance is the square root of a square plus b square. And what is our a? Our a is this one. So you will have x2 minus x1 square, and our b is this one. So b is y2 minus y1 square. Alright, so that is how the formula given in this page is obtained. Alright, thank you very much for watching. See you in the next video.